So hey folks, this is not going to be a karaoke slide deck. This is actually prepared by me. But it's about risk and risk management, which is equally fun. I'm going to promise you. So this is me. My name is Robin. I've been an SRE for most of my career. I'm currently a product manager reliability at Molly. Molly is a payments service provider. And as product manager, I'm responsible for reliability engineering. I'm also part of the SRE NL meetup group. The meetup group, I'm the organizer. We host 2 events, or 1 event each 2 months. I'm going to have a QR code with a link in it for later on if you like this talk. So the most exciting talk today, right? Risk management, don't you think? I understand if you saw this topic, you were like, this is going to be dull. It isn't. By the end of this talk, I've given you like 3 examples of actual implementations which you can use on your daily life if you're like a DevOps engineer or a platform engineer or an SRE. But first, risk management. What is it and why do we do it? Well, at Molly, we have risk management to mitigate risk because we process payments, often your payments. And I'm pretty sure that you would like to trust us processing your payments. Risk is not about systems. It's about data. We keep your data safe, and often data is classified in a certain way. It's CIA, and it has nothing to do with this organization from the States. It's about confidentiality. So we make sure that not everyone is able to access your data. It's about integrity, so that if you put any payment in our system that you know for sure, it's going to get out the same way as you put it in. And it's about availability. We want to make sure that your data is available whenever you need it. And then we have this thing around audits, and it's basically a bit how risk works. Audits validates your design, so that's the way we promise how we mitigate risks. And it's about validating the effectiveness of your implementations. There's 3 sources that we use for requirements on risk. There's regulation. This is the law. This is something that we need to adhere to. GDPR, Sarbanes-Oxley, DORA, they're all examples of risk regulation. And it's often very loose in requirements, it's super fake text, but it is something that we need to adhere to. Then we have frameworks. These are often used for giving your customers more confidence in your products. They are very strict in requirements, so that there's actually dedicated auditors that check the requirements, and if you fulfill those, so that you get your sort of like certificate that you can show, hey, I'm SOC 2 certified, or I'm ISO certified, so that your customer knows they have their shit together, right? And then you have policies, and policies are often self-inflicted. They're owned by your company, and they include the requirements set by your company to fulfill those risks. You can write your own, because basically, as engineers, or as an engineering community, you are the first line of defense for risk, meaning that you can describe how you deal with risks. Today, I would like to focus on DORA, and those are not the DevOps metrics. If your assumption was this is about the DevOps metrics, and this is about like deployment frequency and change failure rate and all those things, I'm very sorry, it is not. It's about DORA and SRE. So what's a DORA? Well, it's the Digital Operational Resilience Act, and it is regulation to ensure that financial institutions are all set to handle, address, and bounce back from disruptions and threats to keep things running smoothly and protect the confidential integrity and availability of your data. Whew. This is too long, right? Basically, it means all our financial organization needs to try their best to keep your data safe and be available whenever you need them. And this is a good thing. You want your banks to be there when you need them, anytime. So let's bring SRE to the game, folks. Site reliability engineering. I assume that most of you are very familiar with site reliability engineering. Nonetheless, SRE is what you get when you treat operations as if it's a software problem. And that's basically what we do. It's basically focusing on these topics: monitoring, incident response, postmortems, testing release procedures, capacity planning, development. And what we do as SREs, we automate and create tools and guidance around these topics. It's not only technical, it's also social technical skills. We bring these skills to our organization to cover all those topics. And basically today is what you get if you treat risk as if it is an SRE problem. So let's take the same model and see what DORA wants us to do. It wants us to identify and inventorize and monitor our systems. It wants us to respond whenever it's needed. It wants us, and it's actually true, it wants us to learn from those outages. And it wants us to test our systems and procedures on resilience. It wants us to manage our capacity. It wants us to have procedures in place to change our systems. Basically, it says you need to have some sort of version control. Let's say Git. You need to have a deployment system. And it tells us that we need to understand how critical our business functions are to our company and what systems support them. Actually, it makes a lot of sense, right? But how did I get here? Well, actually, I read the Act. And it's not an easy thing. And I took some quotes out for you folks, and I needed to shorten them because otherwise it didn't fit on the slide. But basically it said, you need to identify, you need to detect, you need to alert yourself and respond, and you need to test your systems. So I'm going to dive a bit deeper into those topics. Oh, and basically the Act is like 72 pages long, but there's all kind of like addendums that you can read as well. It's fun. So I'm going to help you translate this. So it says something about financial entities shall identify all sources and something, their ICT-supported business functions, information assets, and ICT assets. Assets, this is what it means. A business function, that's the thing your customers are using. ICT assets, those are your systems that you maintain with all your pride, right? We have these great systems. These services and their resources, right? Those are the infrastructure resource that you need. And then you have those information assets. That's the data that flows through that system to provide the data to your customers. See? It's not that hard. So how did we actually identify and detect these assets? Well, this was quite simple for us. We had this internal developer platform called Backstage. And Backstage comes with a catalog info YAML file. And you can put in your catalog info YAML file whatever you like. Like, what is the name of your system? What type of system is this? How critical is this system? What languages are you using? And we processed those catalog info YAMLs, and we standardized tags and telemetry. So we used our standardized libraries, and we added like our standardization, and we added tagging in our standard libraries. We created an observability pipeline so that we made sure that all the tags were consistent, because otherwise we ended up, we actually had 3 ways to say production. We had PRD, PROD, production. It didn't make sense at all, so we have sort of like a pipeline that actually checks and corrects these tagging. It's also quite nice to prevent or to lower the blast radius of like a cardinality explosion if it happens. And I can tell you folks, if you have like a SaaS product for your observability, this is a good thing to have. We use distributed traces and synthetic test to understand the dependencies between our systems and the business functions. So we use synthetic tests to test those business functions, and we gave tags, so the tags flow through the systems, and by using distributed traces, we could recognize which systems were supporting those business functions. But it worked the other way around as well. By having all these distributed traces in place, we could actually identify patterns and identify business functions that we haven't set ourselves yet, which was pretty cool. We used Spotify's Backstage system model as a foundation. And we created like our own little service to push that information into our observability platform. Making way for something that like us product managers like to call the single pane of glass for teams, right? That's the only page you're gonna need while firefighting. It's not true, but it's a great starting point because it's gonna give you like your metrics, your traces, the infrastructure that supports your systems. It's going to give you like your SLIs in one place, your SLOs, your error budgets, basically anything that you need to get going on your reliability. And it's a great thing to offer as reliability engineers. It also gave way to scorecards, where we actually basically scored our systems, mostly like binary checks, right? Either yes or no, this exists or not. This is a great guide for teams. Teams could go to the scorecard, see like, hey, this is something I miss, and we give guidance on how to improve those. But it also doubles for us to validate if we actually adhere to the design that we created at first. Next topic, incident management processes. This is actual title in the DORA Act. And if you don't believe me, it's Article 17, so you can see for yourself. This basically means incident response and managing your incidents. So let me start off like the trigger for incident response detection, right? DORA required us to have detection mechanisms in place to detect anomalies throughout our systems. Yes, it actually said that. It also forced us to understand the criticality of our system, so what was actually critical to us. Spoiler alert for us, it was money. And it helped us driving the adoption of SLIs and SLOs, because we all know how this works in organization. You have this great plan, you're like, hey folks, if we implement SLIs and SLOs on our independent services, everything is gonna be fine. And then you come to like the product team, with the product manager says, this is a great idea, but not today. Today I'm busy. But DORA, as like a regulation, gave us sort of like a tailwind to tell them like, hey folks, this is law. You don't want to end up in jail, so please implement this. So it gave us like a sort of like a tailwind to have SLO-driven monitoring. However, setting good SLIs is a lot of work. So we use Google's Art of SLO as foundation for our workshops, but still, setting an initial SLI is at least a 2 to 3 hour workshop to define like the critical user journey, do some like system diagramming, and identify the points which are important to the system. So I can highly recommend looking at the Google's Art of SLO workshop. It's open source, it's free for everyone to use. We created the chatbot. We actually call it the incident bot. It's a bot in Slack, and it helps you during your incident process. It helps you paging other people when you need them. It makes sure everyone adheres to this process. And it gets me back to the validation of your design. We designed an incident process, and now we need to validate the effectiveness, and we need to make sure that everyone uses the same process. This was not just for DORA, by the way, it was also for other certifications and frameworks. So we used a bot for this, because the bot made everyone's life easier, and by using the bot, everyone used the same process. It gives a status summary for everyone in the company, and it saves you a lot of like stakeholder management while firefighting. It populates post-mortem. It keeps track of all these things that happens while having the incident, right? And it gives you a bit of like a write-up. It automatically creates like a sort of like an impact assessment. For us, transactions are super important. We earn our money per transaction. So every time we have like a sort of like an outage, we calculate the number of incidents that we did not process and that we should have had processed, and we can get to an actual amount and that's neat. And we use the same bot during our resilience tests, so that we know for sure that we don't just test system resiliency, but we also test the capability and train responders to respond to these outages. Lastly, resiliency test. we tiered up resiliency tests because it's this massive thing where you need to test all your systems on their resilience and all your people on their capabilities to respond to outages. It's inspired by Google's disaster resiliency test, disaster recovery test, it's wrong. And it's actually tiered up in 3 tiers. The first tier is the largest one. These are like organizational-wide resilience tests. These are often referred to business continuity tests. It involves your board or your C-level. That's fun. You can do like a little game with them and test them. And you test your existential crisis situations. Things that if they go wrong and it lasts longer than like a week or a month or, I don't know, half year, your business will go down. Tier 2 is, for us, shared systems. Think of your Kubernetes platform. Think of your database platform or your load balance or the larger scale platforms. Often this is referred to as disaster recovery testing. So those are our tier 2 tests. And then we have a third tier where we test individual systems. We refer to them as game days. They're a lot of fun. We do them with teams that manage individual systems. And all these tests, they validate our SLIs, SLOs, but also the recovery time objective and the recovery point objective. That's basically related to the recovery point of your data. And all these tests you can use to validate these, which your auditor is going to like. I want to dive a bit into our third tier testing, which is game days. It's inspired by Datadog's game days. It's a 2-hour team event where we're actually going to do real-world disruptions, and we're going to do real-world incident processes and incident response, and we're going to do real-world post-mortem, just like actual production incidents. It's perfect to build confidence. One of the first services we used for the game days was an actual new release of a new feature, and the folks were a bit scared, like, hey, what can we expect? We did a game day with them to build up their confidence to actually release their feature into production. It's a practical implementation of the chaos engineering principles. I'm not sure how many people are aware of the chaos engineering principles. Oh, you're all so cool. But this is a practical implementation. I know for some organizations, I work in other organizations, chaos engineering can still be a bit scary, and it's this entire thing that everyone wants to have, but everyone is a bit too scared to implement, because most of people would like to have perfect chaos engineering drills, right? Game days is very practical. But it's not just about testing system resilience. For us, it's important that we train our on-call responders, that we test our observability system, that we test our incident and response and mitigation tools, that we test if our alerts are actionable and if they actually help you mitigating the incident. It's not so much about how the system responds per se. This is a good side effect, but it's mainly to train your people. And it's being done in a psychological safe environment. There's not a lot of stress, and that's also good. I'm going to give you an example. We use the Chaos controller, which is made by Datadog. It installs an operator, CRDs, and webhooks into your cluster. It targets nodes and pods and containers, and it injects disruptions via command lines. This could be container disruptions, CPU distress, disk failure, network disruptions. It could be any type of disruption, basically. And it basically works like a sort of like a YAML manifest that you inject into your cluster. But honestly, it's not so much about a tool. This tool fits best to us. There's other tools out there, like the Chaos Mesh, like Chaos Monkey. Do whatever works for you. It could also be just kubectl and then bring chaos to your clusters. That's mainly, the main goal is to create these real-world disruptions instead of do like a theoretical tabletop game. Learnings. Write policies to explain how you manage risk and what principles you adhere to. This worked best for us. We wrote our own resilience policy where we actually dictate that we want to have observability in place, that we need to have SLIs in place, that we want to do resiliency testing through like game-based and chaos engineering. And because these things are important to us, we put them in a policy. And all of a sudden, this is the rule for everyone in the company, which is quite nice. Tag your system and propagate those throughout your observability. It's going to help you understand the importance of your systems and what their role is in your business functions. Apply automation to otherwise dull systems. So we used DORA as like a tailwind to prioritize automation of observability tools, automation like incident bot, which makes it fun for people. Test real-life scenarios, because that could help you test actual real-life events, and it shows you the effectiveness of everything that you designed so far. And lastly, be pragmatic. kubectl allows you to create disruptions as well. Thank you so much. These are all the inspiration I had. I know it's a bunch of QR codes, so take a picture. Thanks for having me.